Okay, in 35 through 39, what we want to do is to find the second derivative. And remember that the second derivative is just the derivative of the first derivative. So it's the d dx of dy dx. And because of the way the notation works there, you see those two d's kind of next to each other, so we say that's d squared y over dx squared. Okay, and so that is just notation for the second derivative. And so we're going to go through this and find the second derivative of x squared plus y squared equals 36. Remember, this is a circle centered at the origin, radius 6. Alright, so we have the derivative with respect to x of x squared plus y squared is equal to the derivative with respect to x of 36. From the left side, derivative of x squared with respect to x of x squared is just 2x. Derivative with respect to x of y squared is 2y y prime. Derivative with respect to x of 36 is 0. So we have 2x plus 2y y prime is equal to 0. We're going to isolate the y prime, and we get 2y y prime is equal to negative 2x, and we've done this for, if not for the same exact circle, for similar circles at the beginning. And so we know that y prime is equal to negative x over y. That's the first derivative. That's in blue at the top there. That's dy dx of y prime. Now we need to find the derivative of that with respect to x. And now you might notice that it's a little bit different. We don't have an equation anymore here. Now we just have an expression, which is y prime, and we want to find the derivative of that expression. In this particular case, we have a quotient, so we're going to need to use the quotient rule. That's low d high if we call the numerator negative x. So the derivative of negative x is negative 1. So low d high minus high, which is negative x. Don't forget the 2 minus. It's minus negative x. So low d high minus high, d low, the derivative of y is y prime, and over low squared, which is y squared. Now in simplifying that, I'm going to put the positive term first. The xy prime is going to become positive and the y is negative. So I just move the positive term first over y squared. Now I can't leave it in this way because I have the y prime in there. And we've talked about this in class. What I do with that, since y prime is equal to negative x over y, I'm going to substitute negative x over y for y prime in the second derivative. Okay, just as we discussed previously. And when I do this, I end up with x times negative x over y minus y over y squared. Multiplying out the numerator, I'm going to get negative x squared over y minus y over y squared. And I shouldn't leave a fraction within a fraction. The easiest way to handle this would be to multiply top and bottom by y. Just make sure you distribute the y in the numerator to both terms. And so we're going to, in the first term, the y's will cancel and we'll get negative x squared. Then distributing the y, we're going to get negative y squared. And that's all over y cubed. Now we did say that we can factor out a negative 1 from the numerator, and we have negative 1 times the quantity x squared plus y squared over y cubed. And sometimes this is going to happen. If you recall, we do have this definition that x squared plus y squared is equal to 36. And since I have an x squared plus y squared in the final form, I can now swap that out and put that as 36, and it's going to be negative. And my final answer for the second derivative is going to be negative 36 over y cubed. And in this case, in the first derivative, the radius of the circle didn't factor into it. But in the second derivative, the radius does factor into it. And it may turn out to be just the radius over y cubed. Maybe the second derivative of a function centered at 0. Of a circle centered at 0. But you'd have to do a few more of those to be confident that there is a pattern there. Alright, so this is problem number 35. We'll go on to number 37 and to number 39 in this section here.